Alright, now I'm going to go ahead and solve a question you can see over here. I'm interested in finding the complex Fourier series of this particular function. It's a discrete function. When I have less than 0, between minus pi to 0, I have, well, 0, which is good. And in the positive 0 to pi, I have myself an x. Okay, so what I will do is actually I'll go back to the previous segment, and this is pretty much it, what I need to use. Okay, the main goal over here is to first find the Cn, and then plug it in here and do it. Okay, but if you choose to not to watch the rest, just want to highlight that there will be a caveat down the road, so at least watch the very end of it. You will see there's something not working as well as we want it to be. Okay, so anyways, let's proceed with the approach. Here's what it says: Cn is equal to 1 by 2p integral minus p to p f of x. I simply copy what is written up there, minus I and pi x by p dx. Okay, so obviously the very first question that I need to ask myself is, what is p? And it's kind of obvious, p is equal to pi, and those things are very close when I spell it out, so it's kind of, sometimes I make mistakes. So this p is pi, this p is pi, so if this is pi, you can see these two cancel, right? It becomes nx. Good. Again, the integral limits are pi as well, but I don't want to write it. Okay, so let's go back and do it. So I will get myself 1 by 2 pi integral from 0 to pi. Did you see what I write 0? E to the minus I n x, right? You've seen that as well, dx. Okay, so it doesn't look too bad, right? Let's be honest. The thing that I have to do is integration by parts. I'm going to call u is equal to x, dx is equal to du, right? Well, it's the other way around, but that doesn't matter. E to the power of minus I n x dx is equal to dv. And I got myself v to be, let me be careful over here, minus 1 by I n e to the minus I n x, right? Yeah. So then I go back and I rewrite this 1 by 2 pi. Let's make a big parentheses. So it's going to be uv. So that's going to be x by minus in e to the minus inx. That's the first one. And I need to let this from 0 to pi. Plus y plus, I'll show you, because I had a negative sign. Negative negative becomes positive. I have 0 to pi. And I have myself 1 by in e to the minus inx dx. Okay, let me take the integral of this as well, so I can write a nice formula 1 by 2 pi. And then I have myself, the reason why I did this was, I'll show you something. When I multiply this by I, both the numerator and denominator, you do see that the minus I squared becomes minus 1, but there's another minus, so that becomes plus. Okay, so when I multiply both numerator and denominator, I get myself ix by n e to the minus inx, and then I'll have, when I take the integral for that, I got a negative 1 by I n square e to the minus inx, and I have to evaluate this whole thing from 0 to pi, 1 by 2 pi. So for the first term, when I insert 0, as it's multiplied by 0, that will be gone. So I simply write, wherever I see x, I also write that pi. I pi by n e to the minus I n pi, right? Okay. Okay, so let's do something. I squared, what is it? Minus 1. So minus minus becomes positive. So I'll write this way. Plus 1 by n squared. I hope you've seen that. When I put pi, I'll get myself e to the minus in pi. What is e to the minus 0? Because when I put x is equal to 0, I will get e to the power of 0, which is 1, right? So I'll have this. I think that's it for now. Yeah, this is good. Okay, I'll do this. I will combine this term and this term together, because these are both multiplied by e to the minus in pi. You'll see why in a minute. And I write it this way: e to the minus I n pi by 2 pi, right? And then if I take that, I will get myself I pi by n plus 1 over n squared. But I still have the last term that I didn't touch yet, so that's going to be multiplication of this and this. So that will be minus 1 by 2 pi n squared, right? Now, what I will do is, from the Euler's formula, I will express this. Okay, if I express this, here is what I'm going to get. Let's use another color. E to the minus I n pi is equal to cosine of n pi minus I sine n pi, right? What is sine of n pi? We discussed this many times. That is 0. What is cosine of n? This is going to be minus, right? So this whole thing becomes minus to the power of n. Okay. So if I go at, this is additional information, but it comes in handy. So let's do the same thing for the positive y, n pi, plus I sine n pi, and you can see nothing changed. I still get minus 1 to the power of n. Okay. And sometimes I see this becomes handy, 2in pi. Okay. So this is going to be cosine of 2n pi plus I times sine 2n pi. I mean, it's obvious that sine 2n pi will be 0 because n pi is 0. But this is a little bit different. You can see when it is even, look at it. When it's even, what happens is I get a plus 1, right? So this becomes 1. Okay? I'm not going to rewrite it, but it's from the same logic over here. I can have the negative 1 as well. It's the same thing, right? So from here, I will write this e to the minus 2in pi as well. Okay, so this is just an additional information in case you need it. Okay, so now I'll go back to my original question and insert e to the minus in pi will be minus 1 to the power of n by 2 pi. Okay, I have I pi by n plus 1 by n squared minus 1 by 2 pi n squared. I don't think I can do any more simplification than this. So this is basically what Cn is. Okay, so this is Cn. Right now, I would like to think about this for a minute. Is this okay? Am I done? I can simply go back and insert it here, you know, to the fx that I'm seeing. Done. Full credit in the exam. Is that right? You need to take a look at closely, especially where n is at the denominator. I'm giving you a hint. You can see in here what happens when n is equal to 0. So C0 term. Tell me what the C0 term is from this function. Well, it is 1 over n, so it's not going to work. So what am I going to do? You know? So what am I going to do is I'll go back to the fundamental definition of C0. We had this. So what's this? 2p minus p to p f of x dx. So I'm going to evaluate that as a separate item, okay, C0. And you will see over here that I'm going to get myself 2 pi, p was pi, as you know, and it's from 0 to pi because negative was 0, x dx. So from here I get myself 1 by 2 pi x squared by 2. It did from 0 to pi. So what do I get? I got myself here, 0 is gone. So pi by 4, right? So I got myself pi by 4 for the C0 value. So then if I write and go ahead and write this f of x, it's kind of a little bit different than usual. So pi over 4 will be outside that summation sign. And then I will have this summation sign over n is equal to minus infinity to infinity, but I will write here n is not equal to 0, right? Because I need to be you know, clear on that one, and that's going to be Cn, which I'm copying from up here, by 2 pi, let's make a big bracket, I pi by n by 1 square minus 1 by 2 pi n square, let's close the bracket, times I n x, okay? So this sums up this segment. Thank you for watching this, okay?